So I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the subject Cloud Computing for third year, fifth semester students, 2021 regulation. The topic I'm going to handle is hypervisor key concepts. So first of all, you have to know what is a hypervisor. Hypervisor is a software layer that allows several operating systems to work alongside one another while sharing the same physical computing devices. So the operating system function as virtual machines which mirror entire computing hardware environments in software layers. Hypervisors are intrinsically connected to all virtualization types as they regulate or supervise the entire virtualization process. Originally referred to as VMM, a hypervisor allows a host computer to support several guest VMs by virtually sharing its resources. This can include processing power, memory, and storage. During operation, the hypervisor logically separates each virtual machine from one another and assigns them their own dedicated portion of computing resources. This ensures that the virtual machine operates smoothly and do not disturb each other. For example, if one VM crashes a security or it experiences a security breach, it can be shifted to another. Hypervisor types can be characterized into two main types, including type 1, that is called bare metal virtualization, type 2, hosted or embedded hypervisor. We'll see one by one. Type 1 hypervisor runs directly on the host computer's physical hardware. These hypervisors are typically fast and more efficient than type 2 hypervisor as they interact directly with the host computer's CPU, RAM, and physical storage space. Bypass the need to go through the layer. Allocate all available hardware processing power and resources to the virtual machine. So providing high security, there is nothing between the hypervisor and the host CPU that the bad actor could exploit. So type 2 virtualization is typically utilized by individual users who need access to multiple operating systems but are not concerned with higher latency, such as engineers who are developing or testing software. So type 2 hypervisors also introduce greater security risk for the host as they feature a large security attack surface. So if a bad actor gains access to the host OS, they could then compromise any guest OS that is operating within the type 2 hypervisor. So type 2 hypervisor can utilize a separate management machines or hardware accelerator software. They are available and applicable. Type 2 hypervisor resort to software emulation if the physical host computer cannot provide the required support. Examples are Microsoft Virtual PC, Oracle VirtualBox, VMware Workstation, Oracle Solaris Zone, VMware Fusion, Oracle VMware Server for x86, CentOS virtualization. The benefits of hypervisor: efficiency. VMs can be created instantly using hypervisor, which provide organization with higher accuracy and efficiency when allocating resources for complex workloads. Adaptability. Type 1 hypervisor allows guest OS and their applications to run on multiple different hardware types rather than relying on OS specific or drivers. This is because the hypervisor separate each OS from the host computer's hardware. For example, hypervisor provides more efficient way to run multiple VMs rather than moving multiple servers to complete the same task. Movability. So VMs and hypervisor software are isolated from the physical host computer, which means they can be moved across multiple servers if needed. This means IT teams can easily and seamlessly maneuver changing workloads to different localized or remote virtual servers that feature the required networking, memory, storage, or processing capabilities.